Section 10.5, segment lengths and circles. By the end of this lesson, you should be able to find the lengths of chords, tangent segments, and secant segments. There's three theorems from this section that we need to make sure we understand, and the first one is this. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So, filling this equation in, what this means is that EA times EB will equal EC times ED. Or you can look at it like this, that the two parts of one chord, when they're multiplied together, will equal the two parts of the other chord. Let's try an example. So here we have two chords that intersect, and we need to find the segment length of X. So I have these two parts, which I can say are 8 times 5. My other two parts would be 10 and X, so I'll leave that as 10X. When I simplify this, I get 40 is equal to 10X. Divide both sides by 10, and we get X is equal to 4. Our next theorem has to do with two secant segments. And if two secant segments share the same endpoint outside of the circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of its external segment. So what we're saying here is that EA times EB, the whole, is going to be equal to EC times ED, the whole. So the external segment times the whole is going to be equal to the external segment times the whole. Let's take a look at an example. So here we have to find the value of X, and this is using the theorem we just talked about. So I'm going to have 12, the external segment, times the whole. The whole here is going to be X plus 12, because I'm going to add these two segments together to get the total. Make sure you put these in parentheses. The other part is going to be our external segment, which is 15, times the whole, which would be 24, because I'll be adding together 9 plus 15. We need to remember to distribute when we're solving. So I'll have 12x plus 144 is equal to, that'll be equal to 360. We'll then have 12x is equal to 216 when I subtract 144 from both sides. And when we divide by 12, we have x is equal to 18. Our last theorem is kind of similar to the last one, except you'll have a secant segment and a tangent segment. And this says that if a secant segment and a tangent segment share an endpoint outside of the circle, then the product of the length of its external segment and the entire segment equals the square of the length of the tangent segment. EA is our tangent segment, which will be squared. And this is similar to the last one if you think about it as the external times the whole and the external times the whole. Now the whole segment happens to be the same thing as the external segment, which is where we get this EA squared from. Let's try an example. This says you're standing at point Q about 9 feet from a large circular tent. The distance from you to a point of tangency is about 24 feet. Estimate the radius of the tent. So using this, we're going to go ahead and say 9 times, that was my external, times the whole, which would be 9 plus r plus r. We can rewrite this as 9 plus 2r is equal to the external, which is 24, times the whole, which also happens to be 24. So in simplifying this and distributing, we have 81 plus 18r is equal to 24 squared is 576. When we subtract 81 from both sides, we 495 is 576 minus 81, and then dividing both sides by 18, we get 27.5. So this means the radius of our tent is 27.5 feet long. We're all set, so it's time for our joke. What does Nosy Pepper do? A nosy pepper gets jalapeno business.